Welcome back, everyone. This is part 2 of chapter 1, and this time we will go through some basic tables regarding the units and dimensions. So this table shows some well-known examples relevant to the lengths. Some lengths like Mountain Everest is listed in the middle of tables. So the height of Everest is 10,000 meter, which is 10 kilometer. This might be the one of the biggest landmark on the Earth, and biggest probably and largest physical length in universe would be the distance between the Earth and the farthest galaxy visible, which is 10 to 26 meter. This one shows some examples of the time dimensions, and lifetime of very unstable subatomic particle equals to the 10 to 23 second, and lifetime of mu1 is 10 to the minus 6. The mu1 is one of the basic elements from the proton decay. So 1 day obviously equals the 10 to 5 seconds, which is 24 hours. 1 year, 365 days, corresponding to the 3 times 10 to 7 second. Age of the universe is probably large number and large scale in time, and that is 10 to the 18 second. Next table shows basic units and dimensions of the weights. So electron is probably smallest object in the universe, and that is the 10 to 30 kilogram, and the weight and mass of the proton and neutron is 10 to minus 27 kilogram, which is 1,000 times heavier than the electron. And DNA molecule is about 10 orders of magnitude heavier than proton and neutron. And the human body is about 100 kilogram. And if you look at the dark sky at night, then we are living in the galaxy, which is heaviest object in universe. It's about 10 to the 41 kilogram. So it's pretty small and tiny object all the way to the largest and the heaviest object existing in the universe. So basically scientists use this prefix from time to time to simplify the expression of scientific numbers. So there are a bunch of different prefixes they used in the science, from largest number to the smallest number. So basically they're split by the 10 to 3 scale. So Utah is 10 to 24, but that's pretty large number, so not used much in the scientific expression, but probably tera, giga, mega, kilo, those prefix are most well-known prefix used in science expressions, and probably milli, micro, nano, pico is the prefix using the small to express the small quantity. So basically all the basic quantity of physics expressed with the basic units, and as you can see, length, time, mass is standard SI physics quantities, and their unit meter, second, kilogram, and all other physical quantity like electric current, temperature, amount of the substance and the luminous intensity have their own units, but they should be expressed by the basic physical quantity and their units. So one scale of unit could be converted to the other unit in the same physical quantity, or to express the same physical quantity. For example, 21.5 inches could be converted to the 54.6 centimeter by this unit conversion ratio. So 1 inch corresponds to the 2.54 centimeters. So if you apply the ratio to this 21.5 inches, that could be converted to the 54.6 centimeters. So actually, unit conversion used a lot in physics, and you should remember how to convert that unit to from one scale to the other. So this figure shows the largest mountain in the world, Mountain Everest. It's their second highest peak, K2, whose summit is considered the most difficult of the 8,000ers. So the K2 is seen here from the North China. So elevation of 8,000 meter is expressed by feet unit. So if you apply the ratio between the unit of meter and the unit of feet, that 8,000 meter could be expressed or converted to the 26,247 feet. So same height, but could be defined or expressed by different units. Likewise, this is micrometer, is a tool to usually used to measure very small scale of object. If you measure the thickness of one page of paper, then probably you can use the micrometer. Yeah. So you can use that micrometer to measure the one page of paper, but the uncertainty probably is pretty large. So better way might be to use the micrometer, but with a lot more pages. So this is sort of like a rapid estimating skill. So if you just measure that 100 pages and measure that 100 pages with the micrometer, then there might be something like 6 times 10 to the minus 2, I mean 6 times 10, probably about 6 millimeter. So if you divide it by 100, then one page thickness might be the 6 times 10 to the minus 2 millimeter. So that is probably a better way to more accurately estimate the one page of the paper in thickness, and it is called a rapid estimating. In science, we use the rapid estimating a lot. This is a good example too. Now, try to measure the height of Fibs 5-story building. Now, the easiest way is maybe use the ruler. You have a 3-meter height ruler, and you put that ruler standing up just 2 meters away from your position. And now you have 2 triangles between you and ruler and between you and the building. And you can see here in the right hand side. So you apply the ratio the geometric ratio between those two triangles, you can rapidly estimate the height of the building. So right now, the ratio between this triangle, between the distance u and ruler and the subtracted height of the ruler from your height is 2 versus 1.5, and distance between you and the building is 16 meter. And then what would be the height of this building? Well, as I said, you can apply the geometric ratio to those two triangles. So 2.15 to the 1.5 equals to let's see, the 16 meter versus x. So what could be the x? X equals 1.5 times 16 divided by 2. So that would be 1.5 times 8. So it should be 12 meter. So that 12 meter would be the height of this building. So this is just a very easy and rapid estimating. So that kind of skill could be applied to the many other places. So this is end of the chapter and part 2 of chapter 1. So we will just continue on the part 3 of chapter 1 and next time. So until then, I hope you have a great time, and hopefully I see you all in the next chapter. I mean the next part. Thank you everyone. See you then. Bye.